Hi everyone. So we will start today context-free languages part 3. Yesterday we have seen some questions. We will see some more questions today. And yesterday's concept was कल हमने देखा था कॉन्टेक्स्ट फ्री लैंग्वेजेस और आज का भी टॉपिक होगा कॉन्टेक्स्ट फ्री लैंग्वेजेस. ठीक है. And this is the Telegram channel group. You please join here. I clear doubts, I make announcements, I post questions. So I do a lot of stuff in this Telegram channel. So please, I'll give you 1 minute of time. Please scan it and join the Telegram channel. I'll give you 1 minute time. Please scan it and join Telegram channel. Please scan it and join Telegram channel. Please scan it and join Telegram channel. Okay. Now let's talk about a interesting personality, Thomas Wiggins, the blind enslaved person pianist who crushed Carnegie Hall background. So he was born as a slave in 1849 in Georgia, USA, and he is blind from birth, legally considered as a property. He couldn't speak, couldn't see, couldn't grew up in total isolation, but he had perfect pitch and extraordinary musical memory. What are the achievements that he had? What are the achievements that he had? He became a touring piano prodigy, which means right from his childhood he became a prodigy and he became touring piano prodigy, composed symphonies in his head, played to sold them to played to sold out crowds. Sold out crowds means they all the tickets are sold out across the world, including Carnegie Hall. He couldn't read or see the keys, but still mastered the piano. If you could compose greatness in darkness, you can build your thoughts doubts. You can build through you can build yours through doubt. If you could compose greatness in darkness, you can build yours through doubt. Okay, you too can become great. If he can become great without a blind person can play a piano without seeing the keys, you too can become a great person by working hard. Okay, so now today we will start our session. So yesterday we have seen some problems. Today we are going to see some more problems. Okay, so let us say a power n, b power n, c power n such that n is greater than or equal to 1. Can you build a PDA for this? Can you build a PDA for this? Try it for 2 minutes. Try it for 2 minutes. Can you build a PDA for this? A power n, b power n, c power n. Can you build a PDA for this? Can you build a PDA for this? So you might think that we could build a PDA. You might think that for every A, I will push 2 A's and for every B and C, I will pop off A, which means you may think that for every A, I will push 2 B's, 2 A's and for every B and C, I will pop. You may think that for every A, I will push 2 A's and for every B, I will pop a and for every C, I will pop a. But this language is not A power n, B power n, C power n. This language is A power m, B power n, C power L such that 2m equal to n plus L, such that 2m equal to n plus L, 2m equal to n plus L, 2m equal to n plus L. Okay, so I'll give you one more problem. Try solving this. I'll give you one more problem. Try solving this. A power n, B power m such that n is greater than m, number of a's or more, and n comma m are greater than or equal to 1. Okay, clearly this is not regular. Regular languages cannot do infinite comparison. Clearly it is not regular. Clearly it is not regular. But can you make it? Can you draw a push-down automata for this is the question. Can you draw a push-down automata for this is the question. How can you draw a push-down automata for this is the question. A power n, B power n such that n is greater than m. So what you should do is, For every A, you can, okay, you try for 2 minutes. I'll give you 2 minutes second, 2 minutes time. I'll give you 2 minutes time. You try to do it. A's should be more than B's. है ना? A's should be more than B's. I'll give you 2 minutes time. You try it. You try it. A should be greater than number of B's. So how are you going to do this? A should be greater than number of B's. So how are you going to do this? You can do the ordinary method. Push A's, then for every B pop A. Finally, if A remains at the end of the input, then you can say that A's are greater than B's, isn't it? So what I will do is, I will push A for every A on Z0. I am going to push A Z0 and A on A. I am going to push A on A. I am going to push A. I am going to push A. Okay. A on Z0, I am going to push A. A on A, I am going to push A, which means I am just pushing all the A's. After that, what I will do is, for every B, if there is a, I will pop it off. For every B, I will pop off a. And I'll keep doing this. For every B, if there is a, I will pop it off and I will keep doing this. And I will keep doing this. Okay? And I will keep doing this. Okay. Finally, what happens? All the B's will be over epsilon. All the B's will be over epsilon. Epsilon. All the B's will be over. And what happens? And what happens? And what happens? A's will be remaining on the top of the stack. If all the B's are over and still if A's are remaining, then we can say that number of A's are more. Then you are going to accept it. Then you can say that number of A's are more and you are going to accept it. You are going to accept it. Okay? Okay? Okay, simple, right? Simple question. Now I will do you one more question. You solve for this. The next question is a power n, b power m such that n is less than m and n comma m greater than or equal to 1. N is less than m and n comma m are greater than or equal to 1. A power n, b power m such that n is less than m and n comma m is greater than or equal to 1. N comma m are greater than or equal to 1. How are you going to do this? How are you going to do this? How are you going to do this? A should be lesser compared to B's, which means at the end B should remain. At the end B should remain. After all the A's are over, B should remain. After all the A's are over, B should remain. You take 2 minutes time and do it. I'll give you 2 minutes time. You take 2 minutes time and do it. You take 2 minutes time and do it. I'll give you 2 minutes time. Okay? Try it. Try it. Don't directly jump to the solution. Take a pen and paper and do it. Take a pen and paper and do it. Take a pen and paper and do it. So what is the question? The question is that, so what is the question? The question is that number of A's should be less than number of B's. Number of A's should be less than number of B's. I will do the same thing. For all A's, I will push A's first. For all A's, Z0 is on top of the stack. I will push A Z0, which means I will push A and A is in the input. A is on top of the stack. I will push A. For all A's, I am pushing A's. Then when a B comes, if A is on top of the stack, I will pop it off. I will pop it off. Now for all B's, I will do the same. For all B's, if A is on top of the stack, I will pop it off. I will pop it off. Finally, what has to happen? Number of A's should be less than number of B's. Finally, what will happen? B will be there. and number of A's will be over, leave it as Z0, and you can accept here but don't accept here. If you accept, see, by this part you know that number of A's are greater, by this part you know that number of B's are greater, right? B's are there, A's are over. By this part you know that number of B's are greater, but don't accept directly, because the reason is there can be something like this: A, B, A can be there, A, B, B, A can be there. Now after pushing A, what will you do? You are going to push a, right? And for a B, you are going to pop it. And now you have seen a B, and Z0 is on top of the stack. Now you know that A's are over. You know that A's are over and B's are more than A. But then there can be a after that, right? There can be some other symbol after that. Therefore, just to be sure that after B's there is nothing, you have to scan through entire B's, right? So scan through entire B's, B Z0, leave it as Z0. Scan through entire B's, and after entire input is over, which means epsilon Z0, leave it as Z0 and you accept it. Okay, you have to be careful here. You should not accept it directly. You should see that only B's are remaining, then only you are going to accept it. Then only you are going to accept it. Then only you are going to accept it. Okay. Okay. I'll give you next question. Think about this question for some time. W, C, W R such that W belong to A comma B plus, such that W belong to A comma B plus. W, C, W R such that W belong to A comma B plus. A comma B plus, where C is a special symbol. C is a special symbol. Where C is a special symbol. C is a special symbol, right? So try to find out what the language is. Try to find out what the language is. Try to find out what the language is. What the language is. What is WWR? What do I mean by W power R? W power R means reversal of W. If W equal to AB, WCWR will be ABC followed by BA. ABC followed by BA. ABC followed by BA. Right. So what you should do is, till a C comes, you are going to push everything onto the stack. Let us say this is the stack, Z0 is on top of the stack. Till a C comes, you are going to push everything onto the stack A, B, and after a C comes, you are going to match. B is matched with B, A is matched with A. B is matched with B and A is matched with A. B is matched with B and A is matched with A. B is matched with B and A is matched with A. B is matched with B and A is matched with A. Okay. 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 Now, how are you going to do the PDA? So, initially, A may come, Z0 will be on top of the stack. You just push A, or a B may come, Z0 will be on top of the stack. Push the B, and A may come, A may be on top of the stack. Push the A, and A may come, B may be on top of the stack. Push the A, and B may come, A may be on top of the stack. Push the B, and B may come, B may be on top of the stack. Push the B. Okay, so till you see a C, you are going to push everything. Now once you see a C, C means the center has come, right? Once the center has come, whatever is on top of the stack, A, leave it as A only. And once you see a B, leave it as B only. Either you see a or B. When you see a C, when the top of the stack is A or B, leave it as A or B. Okay, leave it as A or B. Leave it as A or B. After that, you start matching, right? You have to match B with B, A with A. So what does the matching mean? If the input is B and top of the stack is B, match it. If the input is A, top of the stack is A, match it. If the input is A, top of the stack is A, match it. If the input is A, top of the stack is A, match it. Input is A, top of the stack is A, match it, right? Finally, what happens? The entire input will get over epsilon and top of the stack will become Z0. Leave it as Z0 or your wish and then accept it. And then accept it. That is how you do WCWR. That is how you do WCWR. Right? 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 Okay. Okay. Now I'll give you one more question. You try to solve it. Now I'll give you one more question. You try to solve it. Okay. I'll give you one more question. You try to solve it. It is a very difficult question. So I want to tell you one thing here. Till now, all the questions, all the PDAs, all the push down automatas we have seen are deterministic push down automatas, right? Now we are going to see non-deterministic push down automatas. Okay. Now we are going to see non-deterministic push down automatas. Now I will give you one interesting problem. Before going to the problem, we will see one more story. Okay. We will see one more inspirational story. Dasrath Chand, the Nepali rebel who refused to shut up. He is born in 1903 in Nepal under the oppressive Rana regime, which banned free speech, education, and democracy. And he became a journalist in exile, smuggled underground pamphlets and ideas across the borders, knew the penalty was death, but he wrote anyway. He co-founded Nepal Praja Parishad, the first political resistant party, caught and tortured by the regime, and refused to name his allies. He was executed in 1941. He was born in 1903 and he was executed in 1941. Right? He didn't have an army, just a pen and a paper in his hand, just a pen and fire in his chest. If you could risk death to speak truth, you can risk discomfort to chase mastery. Right? So I'll give you one more problem. Now we are going to answer this problem. So now we are going to do non-deterministic push down automata. Let the language be W power R such that W belong to A comma B plus. W belong to A comma B plus. W power R such that W belong to A comma B plus. W power R such that W belong to A comma B plus. Right? So what is this language, guys? This language is set of all palindromes which are even length, isn't it? The length is even because W and WR have same length. Length is even and they're all palindromes. For example, if W equal to AB, what will be WWR? WWR will be ABBA. WWR will be ABBA. Right? Right? WWR will be ABBA. WWR will be ABBA. If W equal to AB, WWR will be ABBA. ABBA. Right? 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 Okay. So how are you going to solve this? See, for AB you have to push AB. How are you going to solve this? Z0 will be on the top of the stack. For AB you are going to push AB, and for BA you are going to pop B and then A, right? But only problem is we don't know where to pop. We don't know the center, right? So for example, if I give A, B, 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 I thought I'll give a simple one. A, B, 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 A, right? Center cannot be here, but center can be here. Why? Because only between two B's there will be a center, or only between two A's there will be a center. So these four places there can be center. Here center cannot be there. Here center can be there, center can be there, center can be there, right? Center can be there in these three places. Center can be there in these three places. Here center cannot be there. Here center can be there, center can be there, center can be there, right? If I give you one more, A, center can be here, or the center can be here, or the center can be here. We don't know exactly where the center is, but we are very sure about one thing. If I have A, B, A, A, B, A, A, B, A, B, A, B, A, B, A, B, A, B. This is not a palindrome. I want to take a palindrome example where center is not present. Okay. If I take A, B, B, A, center is definitely not here. Between A and B, there cannot be center. Center can be here. Center is definitely not here, right? So here the problem is we are not able to find out where the center is, and so we are not able to know when to start popping. We are not able to find where the center is, and we are not able to know when to pop it, right? So what we will do is, whenever there is a chance for a center, chance pe dance, whenever we get a chance for a center, we will dance. Okay, so what we will do here in this case is, whenever there is a chance for center, we will make two copies of PDA. One PDA will assume that center has come, other PDA will assume that center has not come. So I will just show you with the example. See this. See this. Initially, let us say I am in Q0. Initially I am in Q0, right? Initially I am in Q0, then A, initially I am in Q0, then I got A, and top of the stack is Z0. So only one symbol, center has not come. I am going to push Z0. Similarly, if I get a B and top of the stack is Z0, I am going to push B, Z0, right? And similarly, if I get a and top of the stack is B, center has definitely not come. I am going to push A. Similarly, if I get a B and top of the stack is A, I am going to push A. I am going to push B, right? Now in these two cases, if you observe, if you observe these two cases, this case and this case, if you observe these two cases, center has not come. Center has not come for sure. Center has not come, right? But then if A is in input and A is on top of the stack, center has a chance. There is a chance that center has come. Here there is a chance that center has come. Here there is a chance that center has come, right? So what will you do in this case? You assume that center has not come and you just push A. Similarly, when there is a B in input, B is on top of the stack, you assume that center has not come and you push a B, and also you assume that center has come. Also you assume that center has come, right? So when A is there and A is on top of the stack, you pop off assuming that center has come, and a B is there, B is on top of the stack, you pop off B assuming that center has come, right? So we will reach a stage where center has come. So every A on A you match them, and every B on B you match them. Every B on B you match them, right? Center has, so here center has come. So if you observe it, here the assumption is that center has not come. Here we assume that center has not come, and here we assume that center has come. 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 Right, right. So finally what happens? The entire input will be over. Top of the stack will be Z0. Leave it as Z0 and you accept it. Right? It is somewhat difficult to understand like this. I will use a different diagram and explain you what has actually happened. Okay? So let us say this is Q0. Let us say this is Q1 and let us say this is QF, final state. I will take the same diagram, I will take the same push down automata and I will explain you whether center has come or not. Okay, whether center has come or not. Okay, so initially let us say I am in the state QS, I am in the state QS and I am seeing the input A, and on top of the stack there is Z0, right? So initially I will see a, there is no other option, I have to push a, right? So I will be in QS only, I will be in QS only and I will push A onto top of the stack. Therefore, this A will go into top of the stack. 3 A's will be remaining and A will go onto the top of the stack. Right? A will go onto the top of the stack. Now, input is A and A has come. Input is A and A has come. Input is A and A has come, right? So now we have two choices. Now we have two choices. One choice is assume that center has come. Other choice is assume that center has not come. If you assume that center has come, what will you do? You will pop off this A, right? You will pop off this A. If you assume that center has come, you will go to state Q1 and for this A you will pop off A. For this A you will pop off 1A. Therefore, 2 A's will be remaining and Z0. 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 Now, Q1 is not defined on AZ0. Q1 is not defined on AZ0. Therefore, this will be dead, right? If you observe it, Q1 is not defined for AZ0. Therefore, you are going to kill it. Now, assume that center has not come. Now, assume that center has not come. Now, assume that center has not come. Now assume that center has not come. Now assume that center has not come. Then what will you do? If the center has not come, you are going to push A onto the stack, right? So you are going to be in QS only, center has not come, and you are going to push that A onto the stack. Therefore, in the input there will be AA and AAZ0. You are assuming that center has not come, right? Again here top input is A and top of the stack is A. Therefore, there are two chances. One is center may have come and the other one is center has not come, right? Now what will you do if center has come? You will go to Q1, isn't it? You will go to Q1 and you will pop A for A. You will pop A for A, which means A will remain and AZ0 will remain. AZ0 will remain, right? Now if you assume that center has not come, you will simply push A. So QS, you will simply push A, which means A, Z0, 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 right? Now this copy assumes that center has come, therefore it will, for the next year it will pop A. So it will be in Q1. For the next year it will pop A, which means it will be epsilon and it will be Z0. Finally this will go to QF. So at least one machine has reached the final state. Now what about this machine? Again this machine will assume that center has come and center has not come, right? If it assumes that center has come, then what it will do? It will go to Q1 and it will pop. When it pops, A becomes epsilon. It will pop the A, right? So A Z0, and this is dead configuration. For Q1 this is not defined, epsilon comma A is not defined, right? So it is dead. Now it will assume that center has not come. If it assumes that center has not come, then what will it do? It will push a qs a qs comma epsilon qs comma epsilon a z naught a z naught a z naught z naught z naught, right, right, z naught and z naught, right, right. Now on qs it is not defined for epsilon. Qs is not defined for epsilon. Qs is not defined for epsilon, therefore this is dead. Qs is not defined for epsilon, therefore this is dead. So all we have created 1 2 3 4 push down automatas, out of which only one has reached the final state, therefore we will accept it, right? So that is why it is called non-deterministic push down automata, non-deterministic push down automata, because on seeing the same configuration it is doing two things. It is making copies of itself. On seeing the same configuration it is doing two things. It is making copies of itself. That is why it is called NPDA. That is why it is called NPDA. That is why it is called NPDA. Okay. Now I'll give you one more question, you solve it. I'll give you one more question, you solve it. This is also NPDA question. Okay. L equal to a power n b power n such that n is greater than or equal to 1 union a power n b power 2n such that n is greater than or equal to 1 a power n b power 2n such that n is greater than or equal to 1. Okay. Now what we will do is we will create two paths. Okay, you try it for 2 minutes. I'll give you time for 2 minutes. You try it for 2 minutes. You try to do it for 2 minutes. Take pen and paper and do it for 2 minutes. Take pen and paper and do it for 2 minutes. Okay. Okay. So what we will do is one copy will assume that one copy will go and search for a power n b power n, which means on seeing a on z naught we are going to push the a. 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 On seeing a z naught, we are going to push the a. We are going to push the a. Right. Now, on seeing any number of a's, we are going to push a. Any number of a's, we are going to push a. And on seeing a b and top of the stack is a, we are going to pop the a. Right. And on seeing any number of b's, if top of the stack is a, I'm going to pop the a. I'm going to pop the a. Right. Now finally, if the input is over, finally, if the input is over, finally, if the input is over, finally, if the input is over and z naught is on top of the stack, finally, if the input is over and z naught is on top of the stack, finally, if the input is over and z naught is on top of the stack, z naught is on top of the stack, you are going to accept it. You are going to accept it, right? So what does this path do? It is comparing number of A's with number of B's, which means it is doing this language, A power n, B power n. Similarly, you can do the other path where you can test whether A power n, B power 2n is there, right? Which means on seeing a single A, top of the stack is Z naught, I am going to push 2 A's. I'm going to push 2 A's, right? And on seeing any number of A's, A is on top of the stack, I'm going to push 2 A's. I'm going to push 2A's. For 1A, I'm pushing 2A's, right? Now, if I see a B, and A is on top of the stack, I'm going to pop it off. Similarly, if I see any number of B's, A is on top of the stack, I will pop it off. A is on top of the stack, I will pop it off. A is on top of the stack and I will pop it off. So what does this mean? Finally, what will happen? Finally, input will be over, Z0 will be on top of the stack. Input will be over, Z0 will be on the top of the stack. I leave it as Z0 and finally I accept it. So if you observe it, this path is accepting A power n, B power n, and this part is accepting A power n, B power 2n. This part is accepting A power n, B power 2n. A power n, B power 2n. A power n, B power 2n, right? So these two are the examples for NPDA. This is NPDA. Why is this NPDA? See this, on seeing the same configuration A Z0, it is going to two different, it is making two copies. That is why this is non-deterministic push down automata. This is clearly non-deterministic push down automata. Okay. Now I will give you languages. You have to tell me whether they are deterministic push down automata or non-deterministic push down automata, or they are regular. Okay. से पार्टी शुरू हुई है, दरवाजे को गुंडी मारो, कोई नाम डराने पाए, डीजे को आरबीआर को समझा दो, म्यूजिक गलती से भी रुक ना पाए, तकर तकर जो फील करे वो जाके 2 कप कॉफी पी ले, जिसको डांस नहीं करना है जाके अपना बैच चलाए, जी भर के नाच ले बेबी, नाच नाच के तोड़ दे सैंडल, आंटी पुलिस बुला लेगी तो आरबीआर कर लेगा हैंडल, dance to my tunes, your brain should dance to my tunes. Now very interesting topic is going to start. I'm going to give you languages and you are going to say whether they are regular, deterministic context-free languages or context-free languages. Okay, I'm going to say, okay, I'm going to give you languages. Now you are going to say whether they are regular or deterministic context-free languages or context-free languages. Okay. First question is A power m plus n, B power n, C power m. A power m plus n, B power n, C power m, such that n comma m is greater than or equal to 1. Such that n comma m is greater than or equal to 1. A power m plus n, B power n, C power m, such that n comma m is greater than or equal to 1. M comma m is greater than or equal to 1. Now tell me, is this language regular? This language. Now tell me, is this language regular? Tell me whether this language is regular. This language is not regular. Why? Because you cannot do this comparison, infinite comparison. You have to compare A's with B's and C's, and there can be infinite number of A's, infinite number of B's, infinite number of C's. So regular language to karna hi payega. Regular language will not do it. So this is definitely not regular. But is this deterministic context-free language? Yes, it is deterministic context-free language. Why? For every A, you push a A. For every A, you push a A. For every B, you pop a A. And for every C, you pop a C. You push A's for every A. And then for every B and C, you pop. And every B and C, you pop A's. Simple analogic. What is that you are going to do? For every A, you are going to push a A. Initially, A may come. Z0 will be on top of the stack. For every A, you push a A. And for every A, you push a A. For every A, you push a A. For every A, you push a A. Then, whenever a B comes, A is on top of the stack, you pop it off. And whenever a B comes, A is on top of the stack, you pop it off. A is on top of the stack, you pop it off. A is on top of the stack, you pop it off. And whenever you get a C, and whenever you get a C, 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 after B's, A will be on top of the stack, pop it off, and let any number of C's may come. A will be on top of the stack, you pop it off. Finally, input has ended. Finally, input has ended, which means epsilon and Z0 will be on top of the stack. Simply leave it as Z0 and finally you accept it, right? So what is this? This is a deterministic pushdown automata, isn't it? This is a deterministic pushdown automata. You have pushed all the A's. For every B you popped a, for every B you popped a, for every C you popped a, so that number of A's will be equal to sum of number of B's plus number of C's. Number of A's will be equal to sum of number of B's plus number of C's. Number of B's plus number of C's. Right. So what can you say about this language? This language is DCFL. If it is DCFL, it is CFL also, right? Always remember this: regular DCFL, DCFL and CFL. Regular DCFL and CFL. Regular DCFL and CFL. Regular DCFL and CFL. Right. Answer the next question. Answer the next question. The next question is A power m b power m plus n, A power m b power m plus n, c power n such that n comma m greater than or equal to 1, n comma m greater than or equal to 1. A power m b power m plus n c power n such that m comma n greater than or equal to 1. Such that m comma n is greater than or equal to 1. A power m b power m plus n c power n such that m comma n greater than or equal to 1. ठीक है? Is this regular? This is definitely not regular. Anything where there is infinite comparison is definitely not regular. Later I will tell you some rules by which you can identify whether a language is regular or not. For now, keep it simple. Okay? So this is definitely not regular. This is definitely not regular. Okay? Now I will rewrite this language. I will rewrite this language as A power m, b power m, b power n, c power n. Now it is very simple to analyze, right? So for all A's, we push A's. For all A's, we push A's. And for every B, we pop A. For every B, we pop A. For every B, for all A's, we push A's. For every B, we pop A. And once all the A's are over and B's are remaining, we push them. We push all the B's. And for every C, we pop a B. And for every C, we pop a B. So it is clear when to push and when to pop. It is very clear when to push and when to pop. There are no need of making multiple copies of PDA. Therefore, this is deterministic context-free language. Therefore, this is deterministic context-free language. ये है DCFL. This is deterministic context-free language. This is DCFL, deterministic context-free language. Deterministic context-free language, right? And since it is DCFL, this is CFL also. This is CFL also. Since this is CFL, this is CSL also, right? You can remember this. Regular DCFL, CFL, CSL, recursive language, recursively enumerable language. And then there will be one more set, which is set of all languages. There will be one more set, which is set of all languages, 2 power sigma star, set of all languages, which is set of all languages, which is set of all languages. ठीक है? పరువం వానగా నేడు కురిసేనులే ముద్దు మురిపాలలో ఈడు తడిసేనులే నీ వడిలోన ఒక వేడి సెగరేగనే ఆ సడిలోన ఒక తోడు ఎద కోరెనే. So shall we see a story? Shall we see a story? So the name of the person is Dr. Ramesh Mashlekar. Dr. Ramesh Mashalkar. Dr. Ramesh Mashalkar. He grew up in Chawal in Mumbai. After his father passed away, he was raised by a single mother who worked as a cook and a house help. And he did his MTech from UDCT Mumbai. Now it is called ICT, followed by PhD in chemical engineering from IIT Bombay. He is a son of a single mother who is a cook and a house help, and he is able to do MTech and PhD from IIT Bombay. Where are we, guys? What are you doing? People like this are achieving great things. He is a hero. He is a hero for me, and he should be a hero for you all. Okay? Okay? And see what this hero has achieved. Former Director General of CSIR, pioneered innovations in affordable science, intellectual property rights, and polymer engineering, advocated for Gandhian engineering, doing more with less for the more people. And what is impact he created? He is instrumental in India's scientific policy and innovation reforms. He helped fight international patent cases against Indian products, against Indian turmeric and basmati. His journey from slum to shaping global IP norms inspires millions. See this guy. He is a son of a single mother who is a cook and a house help, and see how much he has achieved, right? Where are we, guys? Where are we? आप कहाँ पे हो? किस लिए कंप्लेन करते हो? Why do you complain? When a person without anything is able to do it, why are you complaining? Okay, now do this. A power m, b power n, c power m plus n, such that m comma n greater than or equal to 1, such that m comma n greater than or equal to 1, such that m comma n is greater than or equal to 1, m comma n is greater than or equal to n, such that m comma n is greater than or equal to 1. अभी तो पार्टी शुरू हुई है, ठीक है? दरवाजे को गुंडी मारो, कोई ना अंदर आने पाए, आरबीआर को समझा दो म्यूजिक गलती से भी रुक ना पाए, टकर टकर जो फील करे वो जाके 2 कप कॉफी पी ले, जिसको डांस नहीं आता है जाके अपना बैस चराए, ठीक है? डांस टू माई ट्यून्स, डांस टू माई ट्यून्स गाइस, डांस टू माई ट्यून्स. ओके, so tell me whether it is regular DCFL CFL. Take 2 minutes of time and tell me whether it is regular DCFL CFL. Whether it is regular DCFL CFL. Tell me that. Okay. Take 2 minutes of time. So a power n, b power n, c power m plus n is given. What should you do? How are you going to build the? One thing is for sure, this is not regular. One thing is sure, this is not regular. वो तो श्योर है, वी आर श्योर दैट दिस इज नॉट रेगुलर, बट वी डोंट नो वेदर इट इज डिटर्मिनिस्टिक कॉन्टेक्स्ट फ्री लैंग्वेज और deterministic context free language or context free language. We don't know whether it is deterministic or context free language, right? So now for every a and b, we are going to push a and b. 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 And for every C, we are going to pop first B's and then A's. That's it, simple. I don't want to draw the PDA for it. If you want to draw it, you can draw it. A and B, you push them, and for every C, you pop B first and then you pop A's. Finally, if the input is over and Z0 is on top of the stack, you can accept it. Here it is very clear where to push and where to pop. Here it is very clear where to push and where to pop. Here it is very clear where to push and where to pop. Isn't it? Here it is very clear where to push and where to pop. Right? Here it is very clear where to push and where to pop. So this is definitely deterministic context-free language. Since this is deterministic context-free language, you can also say it is context-free language. Okay. You can also say it is CSL, RE, recursive, everything. Okay. Only thing you cannot say is it is regular. Only thing you cannot say is it is regular. Only thing you cannot say is it is regular. Okay. अभी तो पार्टी शुरू हुई है, ठीक है? So we will do one more problem. We will do one more problem. Tell me whether it is regular or not, DCFL or not. A power m, B power m, C power n, D power n. A power m, B power m, C power n, D power n, such that m comma n greater than or equal to 1. M comma n greater than or equal to 1. Clearly this is not regular. Clearly this is not regular. Clearly this is not regular. Right? So how are you going to solve this? Take 2 minutes of time and think about it. 2 मिनट का टाइम लेके थिंक करना, एक बार सोचना. Take 2 minutes of time and think about it. How you are going to do this? From that you can know whether it is DCFL or not, or from this you can know whether it is DCFL or not or CFL or not. ठीक है, ठीक है. Very simple है. क्या है? A power m, B power m is there, C power n is there, D power n is there, right? So for every A, push yes. For every A, push yes. For every B, pop yes. For every B, pop yes. For every C, push C's. And for every D, pop C's. For every D, you 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 pop C's. Right? Right? So it is very clear that it is deterministic. We know when to push and when to pop. We exactly know when to push and when to pop. We exactly know when to push and when to pop. We exactly know when to push and when to pop. Right? A clear hai. It is very clear whether to push or pop. Right? 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 So this is DCFL. Clearly DCFL hai. Since this is DCFL, it is CFL also. Since this is CFL, it is CSL also. Since it is CSL, it is recursive also. Since it is recursive, it is recursively enumerable also. Right? 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 Okay. I'll give you one more problem. Try to solve this. I will give you one more problem. Try to solve this. A power m, B power n, C power m, D power n, such that m comma n greater than or equal to 1. Such that m comma n is greater than or equal to 1. Right? Find out whether it is regular or not. It is definitely not regular because there are comparisons involved. Right? A has to be compared with C, B has to be compared with D. Right? B has to be compared with D. A has to be compared with C, and B has to be compared with D. A has to be compared with C, and D has to be compared with B has to be compared with D. A has to be compared with C and B has to be compared with D. 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 Right? 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 Take time and tell me. There is no urgency. A has to be compared with C, D has to be compared with D. A has to be compared with C and B has to be compared with D. A has to be compared with C and D has to be compared with B has to be compared with D. Right? So what will you think about it? You will think that let me push all the A's, Z0 is on bottom of the stack. You will think that let me push all the A's and then let me push all the B's. But then the problem is C's, when C's come, you have to compare with the A's, but on top of the stack there are B's. Therefore, definitely PDA is not possible. PDA is not possible. So this is definitely not regular because comparisons are involved, and it is definitely not context free language also. This is CSL. We will see CSL later. Okay, we will see CSL later. It is CFL, CSL. It is CSL. It is CSL. Okay, it is CSL. Okay, it is CSL. I'll give you one more question. Try to solve this. A power m, B power n, C power n, D power m, such that m comma n greater than or equal to 1. A power m, B power n, C power n, D power m, such that m comma n greater than or equal to 1. Okay, with this question we will end this today. Okay, with this question we will end this today. Tomorrow we are going to solve lot of questions. Okay, tomorrow we are going to solve lot of questions. Take 2 minutes of time and think about it. Take 2 minutes of time and think about it, how you are going to do this. Okay, definitely this is not regular because regular languages cannot do infinite comparison. So definitely this is not regular. Now the question is it DCFL or CFL? Is it DCFL or CFL, or is it not CFL at all? That is the question. Is it DCFL or CFL, or is it not CFL at all? That is the question. That is the question. That is the question. Right, right, right. How are you going to do this? It is very simple, right? What is it given? A power m is given, B power n is given, C power n is given, D power m is given, right? So for all A's, you are going to push A's. For all A's, you are going to push A's. For all A's, you are going to push A's, right? And for all B's, you are going to push B's. and for all C's you are going to pop B's. For all C's you are going to pop B's, and for all D's you are going to pop A's. You are going to pop A's. This can be done in push down automata, right? So what will happen? There will be A's and then there will be B's. Now B's, C's will be compared with B's, C's will be compared with B's, and D's will be compared with A's. D's will be compared with A's. Very simple. Very simple. Okay. Okay. So let us end the class with a story. Let us end the class with a story. Tomorrow we are going to solve more problems. From tomorrow class hours will be more. Okay. Atul Kumar, IIT Madras MSc. His background is he grew up in a hill village in Uttarakhand. After the Kedarnath flood of 2013, he and his mother managed the family by carrying pilgrim goods on pack animals along the mountain trails. Earned an MSc at IIT Madras after topping his district and securing top 25 rank in the state board exams. Despite working physically taxing job, he balanced both the study and labor to secure admission in IIT Madras. Why do you complain? What do you complain? How do you complain? How can you complain? See this guy. He has done a job which is physically taxing, and along with that job, he is able to crack IIT Madras. You have everything, guys. You have everything. You are just not working hard. You are in your comfort zone. Get out of comfort zone. See these people, how much they are achieving, right? And what is the impact he has created? He became a powerful symbol for perseverance and belief in education. Someone who turned circumstances into motivation, proving that aspiration transcends origins. Aspiration transcends origins. Okay. Why are you? Why are you? This guy is a hero. We don't have his photo, but this guy is a hero. This guy, Atul Kumar, is a hero to me. He is an Indian. He is an Indian. I am proud to be an Indian. Atul Kumar is an Indian. I am proud to be an Indian. He achieved such things against all the odds, right? Jai Hind. Jai Hind. Jai Hind.